Oof. 10th canto Bhagavatam लिया यहाँ पे. Okay, good. Thanks. So we are live now. Very good. So, good morning, everyone. So we are live. Rohit, you are always first to give attendance. So, all right. So today is a welding, and in welding, there is only one lecture of welding, and we are going to discuss some of the very, very beautiful problems on welding. So can you just tell me whether audio video is okay? Just because sometime it happens. Can you just confirm? Okay, Karmakar, Dwivedi, Kushwahar, Rajput. Can you just tell me whether audio video is okay, so that I will begin? Okay, na? So today is only one lecture of welding. Tomorrow will be automation. Automation also beautiful problem we are going to discuss. Myself and my team, Rohit is one of the team, the very, very dedicated team, who he basically designed all these questions. So we thought a lot about it. Okay, very good. Thanks for confirming. That anyway, PYQ, you are already doing PYQ. And we are also recording PYQ. So there is no fun in basically giving the PYQs in this Abhyas. We have developed a very good set of questions, because in a gate exam sometime they also touch the periphery. Some new things they keep on popping, something keeps on popping. So considering that factor, we have not touched PYQ in welding. So all brand new questions. Okay, na? Initially, just to make you warm up, we have discussed, we have taken some easy problems, but after that it's a classical problem, one after another, very good problems. Okay, so let us see welding. My qualifications, because I think it's a mandatory for the first page to appear like this. Before getting into the problem, for 5 minutes, let us discuss something basics, because my questions are related to this discussion, and in the crash course I have also not covered these things. Okay, na? So maybe 5 minutes we will discuss these fundamentals before getting into the questions. 5 minutes we will discuss these fundamentals before getting into the questions. Now there is a flux in arc welding. There is a flux. This flux, either we are coating on the electrode, or like for example submerged arc welding, we are not coating over the electrode, we are using it as a granular flux, throwing into the welding area, but there is a flux. There are different types of fluxes: acidic, basic, rutile, heavy coated. But in most of these fluxes, some of the major ingredients are these things. Cellulose coated flux is also one of the category. So in all the different varieties of fluxes, these are the ingredients. Okay, na? Cellulose. We add some cellulose. What is the function of cellulose? It's a gas forming material. So when the gases are formed during welding, what is the advantage? What is the advantage? Suppose this is the electrode, and here is the work, and here is the work. So when the gases are formed, these gases will try to help detaching the molten metal from the tip of electrode and attaching to the work. It avoids spatter. Spatter means when the liquid metal is not going to the weld bead, it is going here and there. So gas forming materials are very, very important because there has to be some very strong detaching force. And the drag of this gas is a detaching force. So the purpose of gas forming material cellulose is detaching force. And also it avoids spatter. Correct? Huh? Now there is something called silica. Because before coming to this class, I thought a lot about it. That there should be some fundamentals, especially in this welding. Not just basically I'm doing some questions discussed without fundamental, it's a waste. Correct? Huh? So there should be some fundamental. Silica. Silica is a fluxing material. So when the function of flux is to support the heat treatment, when the function of flux is to support the heat treatment, I would like to have more and more fluxing material, because on the bead, when the amount of silica is more, the slag coating will also be thick. Amount of silica is more, slag coating will also be thick. And thicker slag coating will support the heat treatment of bead. And as a result of that, you will get coarse structure. And the coarse structures are tough. So when the resulting bead, you want toughness, better we will go for high amount of silica in the fluxing material. We will go for high amount of silica in the fluxing material. Such a fundamental, that's the reason I have discussed this thing. Because crash course time was limited, so I have not incorporated these things there. Now, potassium silicate is called arc stabilizer. Suppose there is an electrode and there is a work. I would like to have a smaller and a smaller arc. I would like to have a smaller and a smaller arc. There is a reason for that. Because larger arc leads to a spatter. A spatter is the one I want to avoid at any cost. So when the arc length is small, a spatter will be less. But the problem with the smaller arc length is, there will be short circuit. The electrode may short circuit the work. And the short circuit is a major problem. Because it adds defects. So if we want to maintain shorter arcs, better to have potassium silicate. Because with the help of potassium silicate, we can maintain smaller arcs. See, there is a great science behind this. Whatever I am discussing only sutras. But each and every element, discussions can be further. But for Abhyas and crash course, we have not touched because of the limited time. And the fourth one is ferrosilicate. Ferrosilicate is a deoxidizer. Because what happens when we are performing bead. Let us say this is the bead, and after that there is a heat affected zone. So higher is the heat affected zone means temperature of the material is beyond the recrystallization temperature. Temperature of the material is beyond the recrystallization temperature. That is a heat affected zone. And the bead, it's a melting point. So at high temperature, there will be a tendency both in the bead and also in the heat affected zone to get oxidized. At high temperature, rate of oxidation will be very high. At high temperature, rate of oxidation will be very high. And some of the oxides are really troublesome. So if we want to prevent the oxide formation, add ferrosilicate. So ferrosilicate suppresses the formation of oxide. At least the rate will decrease. At least the rate will decrease. Rate of oxide formation will decrease. So I hope these things are very clear to you. Very, very important discussion. Okay, na? I'm discussing in Abhyas. Now next 2-3 minute discussion is on types of joints, because my questions, initial questions are based on types of joints. And there are, by the way, I'm telling you, there are a lot of confusion among the students. Okay, so that is the reason I thought of discussing with you here. So there are primarily 5. You can say there are 6 types of joints, but primarily there are 5. There are, just look at it, look at the board, and it's very easy. There are 2 pieces of work, first work and second work. Very carefully, because in students there is a lot of confusion. That is the reason I am going through it. 2 work pieces. The angle, this angle is 0 to 5. See the angle, 0 to 5, and I am depositing the material here. Once again, for 2-3 minutes, concentrate on your screen. Please concentrate on your screen. Otherwise, books, it's a mind blowing. You will bang your head, you will not understand. 2 work pieces. Angle between the workpiece is 0 to 5, and I am depositing the material here. This type of joint is called lap joint. For example, soldering, brazing, adhesive joint. It's a lap joint, na? And in this lab, generally in the lab, this material flows by capillary action. Soldering, brazing, na? So angle, there are 2 things we have to focus here. What is the angle and where I am depositing the material? Please focus on these 2 things. Okay. Suppose there are 2 workpieces, first and second. Angle is between 5 to 90. Angle is between 5 to 90, and I am depositing the material here. It's a T joint. It's a T joint. Okay. Now 2 workpieces, first and second. This angle can be 135 to 180 degree. 135 to 180 degree, and I am depositing the material here. It is called butt joint. Okay. Now see, angle is 5 to 30 degree, but I am depositing material on the other side. See this? Other side, not this side. If it this side, it will be T joint. I am depositing material on this side. It is called corner joint. Now 5 to 30 it was corner, 35 to 180, but now 30 to 135 angle, 30 to 135 angle, and I am depositing material on this side. It is called edge joint. Of course, there is something called cruciform joint also. Cruciform. Cruciform. Cruciform, like Jesus was crucified. Crucified. Actually, the name came from there only. Crucified joint. So, cruciform joint. So, there are, you take the 2 materials and weld here. It's a cruciform joint. So, you can say there are 6 types of joints, but primarily 5 are primal. Understand? Na? Focus on the angle and where we are performing the welding operation. That is very, very important. Types of joint. Now there are different types of weld: spot weld, seam weld, groove weld. If you are having edge preparation, it is called groove weld. Anyway, so In the regular courses, we will get into too much detail of these things. But this much information I have given to all of you so that we can work out some problems now. Everybody's ready now? Everybody understood? Just can you tell me in the chat box whether everything is okay? So that I will go for problems. So that I will go for problems. Can you just tell me in the chat box? Can you tell me? Yeah, chat box. Yes, very good, clear. Everything is clear. Now, initial 5 problems are very easy. Very good. Everything is clear. Let us go to problems. If you have understood, now do the problems. First 4 problems are very easy. First 4 problems are very easy. I want answer from you. And first question is multiple select question. First question is a multiple select question. Please give me the answer. A fillet weld can be used to join which of the following joint types? Fillet weld, you know very well, na? Fillet weld is, once again, fillet is not a type of joint, it's a type of weld. So, little bit fundamental I will teach you here. This is called fillet weld. Fillet is a type of weld, not a type of joint. Okay, na? And this L is called leg length. Of course, our design team is very strong. Like we have Negi ji, our HOD, and design Ramanand ji is there, Apurup ji is there. We have very strong team. So they will teach you basically about the design of weldment. So here I want to tell you one concept. Welded joints, always, this is a thumb rule. Please always remember this thing. Fillet welds will always fail through shear and through the minimum cross-section area. And what is the minimum cross-section area? This one, see? Okay, if it is like this. This is the minimum cross-section area. Fillet weld always fails in shear through minimum cross-section area. Now tell me what is the answer. Now tell me, oh my God, Dwivedi, Rishabh, Rajput. Very good. B, C, D. Very good. All of you are champions, really. I really appreciate. I'm not joking at this moment. Many of you are champions because some students were there in crash course. So I'm seeing that you are a champion. Now, second question, I want the answer. It's not MSQ. It is not MSQ, it's MCQ. Yeah. Groove welds. Whenever we say groove weld means edge preparation. Edge preparation. Edge can be anything. It can be V. So whenever we are doing any edge preparation, whether V, U, J, anything, it is called a groove weld. So groove welds are most closely associated with which one of the following type of joint? Yeah, any answer? No. Rohit is correct here. Pavan Dwivedi is correct. Very good. But edge preparation, whenever we are doing edge preparation, primarily it is a but. Very good, Kushwaha. Very good. Once again, I will request you, like I am telling all these names now, you have not sent your phone number to me. Please send, because there is one Kuldeep Rathod ji, he is handling all these database, I will forward it to him. Okay, na? So please, whatever I am suggesting, please send your phone numbers and all that to me. I will forward it to him, my team. Okay, na? Because you are champions. I am hoping that by God's grace, you may get very good rank. So at that time, our team may require some thing from you. Okay. Next question. Tell me what is the answer. These are easy things. Tell me what is the answer. A flange weld is most closely associated with which one of the following types? Flange, you know very well in design. We study these things, flanges. Now tell me what is the answer. Tell me what is the answer. Very good. Up to the first two questions, you have done really very well. Now third, fourth question. So that is the reason I have discussed the joints and fundamentals in the beginning of this Abhyas lecture. Yeah, tell me. What is the answer? Think over it. Before answering, please think over it. Before answering, please think over it. Arey, very good. Prakash Singh, very good, very good. Prakash Singh, very good. It's the age. You know, I think some of you came to know about these joints today only because it appears like that only. Okay, very good. Rishabh, Rahul, Rohit. That's the reason I told you to focus on angle and where we are performing the welding operation. Very good. See the answer. See the answer. Very good. Last easy question. After that, we will get into the numericals. Last easy questions. No. Tushar, no. Except Tushar, everybody else is correct here. Except Tushar, everybody else is correct here. This is the last easy question and it's a MSQ. It's a MSQ, multiple select question. Tell me what is the answer. It's a MSQ. Some of you are basically my students during crash course and I have taught you some fundamentals there also. So give me the answer. Fourth, I'm basically standing side so that you can read the question properly over the screen. You can read the question properly over the screen. Yeah, very good, Rishabh. The amount of heat required to melt a given volume of metal depends strongly on which of the following? Heat of fusion and the melting temperature. See, modulus of elasticity, it will not depend. Suppose you are looking for a spring back, it will depend upon modulus of elasticity. Coefficient of thermal expansion is also not related to that. So B and C. Yeah, very good, very good, very good. So 4 questions were easy. So these are warm-up questions. Once again, our team is recording PYQs. So if you need video solutions and if you need actually, some people will be there, our team, so they will contact you. So Abhyas, for me, I have not taken 90% of the cases, I have not taken any PYQ because of the same reason. Because what is the fun discussing the same question again and again? PYQ, of course, we will give you body video solution, but not an Abhyas. Okay, now funda start, numericals start. Numericals start now. So what I told you, hitting the numerical, make the diagram, write the data, and we will compile the data and then solve it. Okay, na? Let us read it together. Let us read together. A surfacing weld. You know what is surfacing weld? I will give you some background. Rolling mills. Rolls are very expensive. See, once again, I told you in the beginning, in Abhyas, my job is not to get some numerical done without teaching any fundamentals. Then there is no use of Abhyas. Some fundamentals must be learned during this course. So, rolling mill. no matter how hard you try, the work material will react with raw material. And over a period of time, a small amount of raw material will erode. A small amount of raw material will erode. So when the raw material gets eroded, some of us may think, okay, throw the raw, purchase another one. No, we will not do like this. Throw the old roll, purchase a new one. Rolls are very expensive. Rolls are very expensive because the material is high carbon, high chromium steel or chrome steel. And to roll hard material, we use maraging steel, but maraging steel is very expensive. So raw materials are very expensive. So what we do, with the help of a welding process, we coat a layer over the roll. And this process is called surfacing weld. Understood what is the meaning of surfacing weld? What is the meaning of surfacing weld? So each and every detail actually I will explain to you. A surfacing weld is to be applied on a rectangular low carbon steel which is 200 by 350 mm. So surfacing weld 200 by 350 mm. Okay, na? 200 by 350 mm is a plate, and this is the thickness of plate. This is the thickness of plate. So as the data is given, I will keep on writing. Okay, now that's the idea. The metal is to be applied is a harder alloy grade of steel whose melting point is assumed to be the same. Means melting point of work and the melting point of material that you are depositing is same. That's what question says. A thickness of 2 mm will be added to the plate. Surfacing weld 2 mm is added to the plate, but with penetration into the base metal, the total thickness melted during the welding is 6 mm. You know what is the meaning of that? Meaning is total penetration is 6 mm. Out of the 6 mm, 2 mm is a deposited material. 2 mm is the deposited material, and 4 mm is the original parent metal. Original parent metal. Okay, so total 6 mm penetration. Okay, on the average. The surface will be applied by making a series of parallel overlapped welding beads running lengthwise on the plate. Meaning I will perform welding in this direction. This is the welding direction. I will perform the welding operation like this. Okay. Long continuous operation at travel. And the travel speed is 7 millimeters per second. And the welding speed is 7 millimeters per second. Okay. Laid down in one long continuous operation at travel speed of 7 millimeters per second. Using welding passes separated by 5 mm. You know what is the meaning of that? What is the meaning of that? It's a plan. So it's a one pass. This is the second pass, third pass, fourth pass, like that. Between the two passes, the gap is 5 millimeter. Because a surfacing weld, I have to cover the entire width. First pass, second pass, third pass. Between the two passes, gap is 5 millimeter. So on the first page, this information was available and I have written there. Okay. Next page. Gate also long problem comes. Okay, so we have to be careful. Okay, ignore the minor complications of the turnarounds at the ends. You know what is the meaning? because there are end defects. So when we are performing the welding operation at ends, deposited materials melts out. I mean, there will be some grooves. So calculation of deposited material will be difficult at ends. So question says, ignore the end defects. Okay, assuming the heat transfer efficiency is this and the melting efficiency is 0.6. Heat transfer and melting efficiencies are given as 0.8 and 0.6. 0.8 and 0.6. Melting point is 760. 760. Oh, no. 1760. 1760 Kelvin. 1760 Kelvin. And the specific energy, see what is the unit? Millimeter cube Kelvin square. Okay, 3.33. 3.33 into 10 raised to power minus 6 joule per millimeter cube Kelvin square. Sometimes the data is given in this form. Now, the question is the rate of heat that must be generated at the welding source. So, first question is heat generated at the welding source. And the second is how long it will take to complete the surfacing operation. Second is the welding time. Now, I have compiled the data. So let us understand the problem once. I will change the color. Let us understand the problem. See, of course, I will be little slow, but you also solve little bit. Of course, I will solve it, but you also solve. By that, you will be able to learn. So problem is there is a plate 200 millimeter wide, 350 millimeter long. I have to deposit 2 millimeter material over that plate. But when I am depositing 2 material, 4 millimeter is a penetration. Total 6 millimeter melts. 2 millimeter deposited material, 4 millimeter parent metal. Okay, na? The welding speed is 7 millimeters per second. Heat transfer efficiency is melting efficiency. Generally, you make a thumb rule. Sometimes it is called F1, this is called F2. First efficiency, second efficiency. Suppose the power source, how much energy is provided by the power source. Multiply these two efficiency, that much energy will fall on the work. Thumb rule. Everybody, I think all of you will be knowing all these things. One more thing I want to tell you. Suppose the heat is given in this form. Joule per millimeter cube Kelvin square. Try to convert into joules per millimeter cube. That is the correct way of writing. So specific energy is nothing but H1 into T square. So 3.33 into 10 raised to power minus 6, 760 square joules per millimeter cube. Some of the questions, specific energy is given in this form, joules per millimeter cube. But in some of the questions, joules per millimeter cube Kelvin square. So convert in this form. Melting point, it should be in the Kelvin, multiplied with square, and you will get in this form. Okay, na? So now we will begin. So energy supplied by the transformer. Energy supplied by the transformer will be this U. Same energy. Multiply by the volume deposition rate. Volume deposition rate divided by both the efficiencies. divide by both the efficiency, heat transfer efficiency and melting efficiency. So this formula kind of thing you will be using repeatedly. So can you give me the answer heat generated? Do it. Do it. एकश्चंद्रो तमो हन्ति न च तारा सहस्रशः. One moon is better than million of stars. अरे भैया पढ़ लो थोड़ा सा. Why you are spamming? एकश्चंद्रो तमो हन्ति न च तारा सहस्रशः. One moon is better than million of stars. Such people, how you can be happy? I'm giving because I don't care. One person is more valuable than thousands of useless people. Please learn some character. Of course, I will be all there along with you, but along with mechanical production, please learn some character for me. Okay, give me the answer. A option. Arey, very good. Sunil is always. Give me the answer. U. Put the U here. Volume deposition rate, heat transfer efficiency, melting efficiency. Ekashchandro tamo hanti nachatara sahasrashah. Very, very important this sloka. Of course, I read Shastra daily. That is the reason I'm quoting it for some of you. Okay, okay, I want this answer. Heat generated. Yeah. No, my answer is slightly different. I don't know why. This is the U. Heat transfer efficiency is given, melting efficiency. Now, volume, volume deposition rate is basically, this you can write in this form also. This will be true when 100% bead is a filler material. Or you can say area of bead into welding speed. Area of bead into welding speed. Now, it's a surfacing weld. So, what is the area of bead? Total 6 millimeters of penetration. And in the width direction, it's a 5 millimeter width. So, what is the area? Area will be nothing but 6 into 5. And welding speed is given as 7, I think, na? Yeah, 7. So, ये volume deposition rate will be when 100% is the 100% is the filler material. But best way to write is area of bead into V. Now give me the answer. This answer is the first option. This answer is the first option. Yeah, tell me. My answer is 4515 joules per second. Tell me whether it's okay or no. Tell me whether it's okay or no. Tell me whether it is okay or no. Nowadays, people are so disturbed. I don't know how they will have, what they will do in their life. So disturbed. They will not study anything, but they will try to poke others. Such people, they don't have any future. Such people, they don't have any future. Yeah. Yeah. Prakash Singh. My answer, your answer is the same. Remember that it's a bead area. So this formula you should apply very, very carefully. Bead area, because this energy also went into melting the penetration also, na? How much energy is utilized in melting? In melting, so parent metal also you are melting, na? Energy utilized in melting the material. So 4 millimeter parent metal, 2 millimeter the deposited material. Okay, very good, very good, very good. Can you give me the answer of the second question? What is the welding time? I will wait for 1 minute. I want, because some of you are champions, I want some of you to give me the answer. Think over it. Think over it. Then give me the answer. Welding time. How much will be the welding time? Okay. Kanishk. Remember, ekas chandro tamo hanti nachatara sahasrashah. In Hindi, English, one moon is better than millions of stars. Very good. This is correct, na? Energy supplied by the transformer will be this. Or you can say 4.5 kilowatts, joules per second, na? 4.5 kilowatts. I want some of you, oh my God, कर्मा कर. अरे क्या हो भाई तुम्हें, कर्मा कर. अरे you are a teacher, because एक झटके में आंसर दे रहे हो आप सब लोग हैं. Karmakar, are you a teacher or a student? Just I wanted to know, because last 6 days I am seeing your answers are accurate and एक झटके में आंसर आता है. Are you a teacher or a student, Karmakar? Can you tell me please? It will be good to know. Actually, if you are a student, you are a champion. I want the welding time. One time is already there in the chat box, but I want answers from other students as well. Are a student, which university you are from? Because please, you definitely give your number to me. Okay, I am basically waiting on this slide because some people are a little slow, but I want remaining students to give me the answer of welding time. Answer of welding time. Arey, very good. Pavan Dwivedi, very good. See, concept is welding speed is 7 millimeters per second. How much is the total length electrode has to move? How much is the total length electrode has to move? So length direction is 350. So length is a 350 millimeter, correct na? Now width is 200. Width is 200 mm. And after welding, it advances by 5 millimeter. So how many runs I have to perform? Number of runs I have to perform. It is not World Cup run. That means number of times. So 200 divided by 5, 40 times. 1, 2, 40 times entire width will be covered. So how much is the overall length? Overall length of weld 350 multiplied by 40, that many millimeter. Welding speed is 7. So overall time will be welding length divided by V, that many seconds. And answer by Mumbai University, Karmakar, very good. You should definitely send a number to me. 33.33. That's the welding time. So, there is no set formula for welding time calculation. There is no set formula for welding time calculation. It has to come by intuition. It has to come by intuition. Okay, na? See how the welding is being performed. Is that okay with everyone? Oh, most of you are giving the correct answer. Very good, very good, very good. We have our team member, Kuldeep Singh Rathore ji. He is basically interact with each one of you to help you to basically excel well. So your details I will give it to him. Okay, na? All right. Next question. This question we have taken from one foreign author book. That's the reason That's the reason it is a British thermal unit. BTU means British thermal unit. So this question we have taken from a foreign author book. That is the reason it is BTU, Batu, British thermal unit. No problem. Okay. The problem is more or less similar. Just read the problem and then the power source in a particular welding operation generates 125 British thermal unit per minute. So solution, VI is 125 British thermal unit per minute, not second, per minute. Keep on writing the data, okay na? Which is transferred, and you should also know that one BTU is nothing but 1055. BTU is nothing but 1055 joules. Okay na? 1055 joules, which is transferred to a work surface with an efficiency. I told you F1, F2. So these F1, F2 are nothing but heat transfer efficiency and the melting efficiency, 0.8 and 0.5. 0.8 and 0.5. These are basically heat transfer efficiency and melting efficiency. ठीक है ना? Okay. Now melting point is 1800 Fahrenheit. 1800 Fahrenheit. And it's a continuous fillet weld is being made with a cross-sectional area. Cross-section area of weld is given to you. Cross-section areas of weld is given to you. It is 0.04 inch square. This problem is taken from foreign author book. BTU means inch. The dimension of length will be inch in BTU. Determine the travel speed at which the welding operation can be accomplished, given that it is also see Fahrenheit square. 1.467 into 10 raised to power minus 5 BTU inch square Fahrenheit square. So what do you have to find out? Travel speed. You have to find out the travel speed. It's an easy problem, relatively easy problem compared to the last problem. So energy supplied is nothing but U into area into travel speed. Travel speed into area of the bead. That's what we do now. Divided by both the efficiency, heat transfer efficiency and the melting efficiency. Now this U is in the BTU per inch square. So U will be nothing but 1.467 into 10 raised to power minus 5 into Fahrenheit 1800 square. So put everything here. Can you tell me the speed? Can you tell me the speed? Welding speed? Can you tell me the welding speed? I will wait for some time so that you can complete the problem. Yeah. I'm waiting because giving you some time to do calculations. Yeah. Velocity here you will get in something inch per second. inch per second. Okay, and this inch has to be converted into question is asking about inch per minute, I think, na? Multiplied by 60. So answer is 26.3 inch per minute. Answer will be also in. ऐसे कैसे रोहित, ऐसे आंसर कैसे आ रहा है? Pavan Dwivedi answer is correct. Pavan Dwivedi answer is correct, I think. Others, there is some glitch. There is some glitch, it seems. Area of bead is given to you, so I think there should not be any problem. Yeah, Pavan Dwivedi, that's the correct answer, I think. Because my calculation says this one. I may be wrong, because calculation can be wrong, because I'm also a human being, na? Procedure is this, and you tell me whether calculation is correct. As for now, yeah, Pavan and Tripathi, Pavan and AP Tripathi, they are giving my calculations are matching with them. But our captain of Indian team, his answer is wrong. I don't know, generally his answers are correct. Captain of Indian team, his answer is coming wrong, I don't know why. Yeah, now answer is coming correct. What was the issue? What was the issue? Okay, okay. So easy one, na? Easy. Try to see what is this formula. Energy supplied by the energy supplied by the power source or transformer. Energy supplied by the power source or transformer. Heat transfer efficiency and the melting efficiency. This is also called F1, this is called F2. In some numericals, especially this foreign author book, this mention F1 and F2. One thing you should remember, in IITs, who sat gate paper? IIT people sat, our gurus. In welding, they follow 3 books. Because yesterday one of my student, who is a teacher, basically somewhere, I will not tell the name here because everybody knows everyone. So he was telling, sir, actually everywhere people are giving the suggestions of this book, P. N. Rao and Pandey and Singh, Falana Dhikana. Is it correct? I said it's not correct. Unfortunately, although it's live, but it's for benefit of students, I'm telling you all, don't follow each and every book. In welding, 3 books. In welding, I recommend only 3 books and don't follow any other book. One is Welding Technology by Little. It's a very wonderful book, Little, very thin book. Second is a Welding Technology by A.C. Davis. A.C. Davis. And third book is written by my teacher, Professor R.S. Parmar. R.S. Parmar. Only volume 1, because volume 2 deals with the design of welded joints. So for welding, you see only these 3 books. Other books, there are hundreds and hundreds of mistakes, I'm telling you. Don't follow any other book on welding. There are hundreds of mistakes. I'm telling openly because I care for all of you, that you should not do any blunder in exam. In IITs, they don't follow all these books that people are telling in the or live sessions. They don't follow in production. Production, we have to be very, very careful. Okay. So, all correct. Let us go to the next problem. There is some chat box. Only answers are there. Only answers are there. So, let us go to the next question. Let us go to the next question. Okay, color is same, I think. All right. A gas metal arc welding, GMAW. Gas metal arc welding. GMAW is the semi-automatic version of GTAW. GMAW, just a minute. Just a minute, just only sorry for, because there are some important messages I have to respond. Our PW team, okay, na? They have to. Okay, GMAW is semi-automatic version of GTAW, gas tungsten arc welding process. Like submerged arc welding is semi-automatic version of shielded metal arc welding. Anyway, these things we will discuss wherever there is a time. Okay, na? So it's a semi-automatic version of GTAW or tungsten inert gas. Both are same. So a GMAW test is performed to determine the value of melting efficiency. So solution is, I have to find out melting efficiency. Okay, na? As the question is asking, I am writing the data. Okay, na? In exam, please do the same thing. In the rough copy, as we're reading the question, na, try to make some diagram or write the data. Then take a deep breath and then see the data. Don't read the question. You should read the question again only when there is a confusion. Otherwise, data is in front of you. Okay? So that way you should do it. That way you should do it. Okay? For a certain metal operation, the welding conditions are voltage and currents are given to you, 25 and 125. Voltage is 25 volt, current is 125 ampere. Okay, I am writing the data. This is the voltage and current supplied by the transformer. And heat transfer efficiency is assumed to be 0.9. Heat transfer efficiency is assumed to be 0.9. Okay, I am writing the data. The rate at which the filler metal is added to the weld is 0.5 inch cube per minute. Inch cube per minute. Volume deposition rate. Okay, volume deposition rate of filler metal. Okay, and measurements indicate that final weld bead consists of the final weld bead, na? This weld bead. This is the bead. Final weld bead consists of 50% filler material, 50% filler material, and the remaining 43% work, parent metal, base metal. The unit melting energy for the metal is known to be, 75 British thermal unit per inch cube. I have written correctly, na? Yeah. Find F2. What is the travel speed? Means welding speed. if the cross-section area of the weld bead is cross-section area of bead is 0.05 inch square, 0.05 inch square. So what is the travel speed? So this was the question. This was the question, and this is the data. Okay, you digest. I will wait for 1 minute. You first of all digest everything what is given. You first of all digest everything what exactly is given. Digest everything what is exactly given. Huh? What is our, this is the given data, okay na? So what formula we are operating? Energy given by the power source is nothing but U, cross section area of the bead, welding speed, divided by heat transfer efficiency and melting efficiency. Okay, that's not a formula we are operating, and it's a very important formula. Okay na? Okay, if you see the data, it is given in BTU inch. BTU inch. So the energy given by the power source is V into I, 25 into 125 watts. This is only in watts, and the right hand side data is in the British thermal unit. So convert into BTU, and what was the 1000? 1055. 1055. Now it is in BTU. Correct, na? It is in BTU. Correct, na? Now solve it. Correct? Now solve it. I will give you, I think there is some. No. Pavan Dwivedi? Yeah. Karmakar given the answer to Pavan Dwivedi. See, Pavan Dwivedi is this one. 1 BTU is 1055 watt. $1,055 joules. Yeah, no, not same. Joules. Okay, that's the way it will go. That is the way it will go. Okay. Now here, focus on here. Area of bead into, this is a little technical point here. There's a technical point here. Area of bead into the welding speed. It's a bead area and the welding speed. Welding speed. But you know, in the bead, filler material is only 0.57%. 0.57. that will should be equal to 0.05. That it should be equal to point, no, sorry, this one, 0.5. 0.5. Area of bead multiplied by welding speed, and in this 50% is the filler material, and volume deposition rate of the filler material is 0.5 inch per meter cube. So this you got AB into V, calculate from here, put it here, and then you will get melting efficiency. Just let me know how much is the melting efficiency. How much is the melting efficiency? Understood, na? But remember, it is an inch cube per minute. Convert into second. Convert into second. Inch per minute cube. Convert into second. Because here I have to inch cube per second, so that my answer comes right. Now, what is the melting efficiency? I want the answer. What is the melting efficiency? What is the melting efficiency? Take a time. What is the melting efficiency? Anyway, these two questions, previous one and this one, we have taken from one foreign author book. That is the reason. That is the reason BTU came into picture. That is the reason BTU came into picture. Oh. That is the reason BTU came into picture. Remember this one. One BTU is 1055 joules. And this is what? I want melting efficiency. I want melting efficiency. Use this formula. Use this formula. Change color, I think. Yeah. Use this formula, see. Think over it before doing anything. Think over it. Units on the left hand side and the right hand side should be same. Units on the left hand side and the right hand side should be same. Now, Naresh Kumar. Now, correct me. Your doubt is clear, na? One BTU is 1055 joules. This energy I am keeping in watt, because I was thinking I am putting it here. Now this is correct. Now give me the answer. Okay, na? Parmar, are you basically joking, Parmar? R.S. Parmar was my teacher basically. R.S. Parmar was my teacher actually, Professor R.S. Parmar. So anyway, you focus on whatever we're teaching. Parmar sir book will be good for you. R.S. Parmar volume 1 if you want to have detail. Melting efficiency, I need answer. Give me the answer of melting efficiency. I will wait for 1 minute. Give me the answer for melting efficiency. Unit should be same on left hand side and right hand side. Unit should be same on left hand side and right hand side. नहीं त्रिपाठी, आई थिंक ये आंसर मैंने नहीं निकाला था एक्चुअली. But take a time 1 minute. Take the time 1 minute, and because my calculation shows slightly different answer. One BTU is 1055 joules. One BTU is 1055 joules. Karmakar. Once again, let us discuss again. because sometimes mind gets heated up. Okay, na? I also do mistake, quite possible. Okay, na? I'm not God. I do mistakes. Okay, na? The person who says I never do any mistake, he should be bluff master number 1. Let us look at it again. Energy supplied by the power source. I am responding to Karmakar. I am responding to Karmakar. Energy supplied by the power source is equals to specific energy. This specific energy will be joules per millimeter cube. I mean, it depends upon which unit. I mean, energy per unit volume. Specific energy multiplied by area of bead multiplied by the welding speed. Area of bead, in the bead area there will be filler metal and there will be parent metal, but we are melting, na? We are melting the parent metal also. So to melt the parent metal, from where the energy is coming? To melt the parent metal, from where the energy is coming? From here only, na? From here only the energy is coming. So that is the reason we will calculate the total bead area. Although in bead, filler metal is also there and the parent metal also there, but to melt the material, both filler and the parent metal, energy is coming from here only, na? That's the reason I will take bead area multiplied by the welding speed. Bead area and the melting speed is the volume per unit time energy we are supplying. Okay, now in this I know VI, it's a watt, and the U is in BTU. U is in BTU, so you have to multiply by 1055 to get the these two units same. Now I want to calculate melting efficiency. Oh sorry, it's a laser. Sorry, it's a laser. I have not selected the correct one. Now I want to calculate AB into V. So AB into V, in that, you know, one data is given to us. What is the data? Filler material is deposited at a rate of 0.5 inch cube per minute. Volume at which the filler material is deposited, that volume rate is given to us. So AB into V is the total bead. In that bead, 57% is the filler material. So if I multiply it by 0.57, it's a rate at which filler material is deposited. Now this will be equal 0.5 inch cube per minute divided by 60. So by that you will get AB into V. Put it here. You will get the melting efficiency. Now what is the answer? Now this answer is matching with me. Vishal Kushwaha, your answer is matching with me. 41.13. 41.13%. That answer is matching with me. Other students, नहीं, अरे भाई, 1 BTU is 1055 joules. ऐसे कैसे हो जाएगा? अमारा ऑफ मैकेनिकल ऐसा नहीं होता. No. Karmakar, we have to add. Once again, because little crucial, I would like to little hover around on this point. Once again, all of you here, there's an advantage of live. If it is recorded, I will not be able to know what is the problem. See, this is the energy supplied by the power source or transformer. Power source or transformer. Now, energy supplied by the transformer goes in two ways. First is melting the electrode or filler material, and second is melting the parent metal, because penetration mostly it's a parent metal. So this energy will go into melting the filler metal and the parent metal. So that is the reason here I am taking the bead area, because bead contains both filler metal and the work metal. So total energy, how much it is required, coming from here. into the welding speed. Okay, na? But now I don't know this factor. So one data is given to me. In the question, one data is given to me that volume rate at which the filler material is deposited is 0.5. This data is given to me. So this is my bead multiplied by 0.57 is the filler, because the filler constitute 57%, will be equal to 0.5. Convert into second by dividing by 60. You will get A into V and the melting efficiency. Now it's okay. Now it's okay. Yeah, very good. Yeah, see the question one more time. See the question one more time. Pavan Dwivedi, you can take the screenshot also. You can take, please, screenshot also. Okay. Okay. This is the question. I am on the request of Pavan Dwivedi. Dharmakar. Okay, good, good. Now calculate the second question. What is the travel speed? What is the travel speed if the cross-section area of the weld bead is 0.05? That's an easy one. It's an easy one. Here itself we can solve it. So area of bead into V, area of bead into V, we have calculated na before. Area into B we have calculated before. So that value will come here. Okay. And cross section area of the weld bead is given 0.05. Find out the welding speed. Find out the welding speed. My answer is coming 44.5 centimeters per minute. Inch has to be converted into centimeter. So this answer is coming from my side. Just check it once whether it is okay. Just check it once. Okay. All right. So this was the second part was bit easy. Second part was bit easy. Now let us go to the next problem. Let us go to the next problem. This is slightly different. Next problem is slightly different, and I want answer from your side. This question is a very beautiful question. 8th question is a very beautiful question. 8th question is a very beautiful question. Inch, Rohit, inch you can convert into centimeters. Okay, na? 2.54 centimeter. Now you forgot about that thing. Till now, whatever questions we discussed, primarily it was the same pattern. Now I'm changing the pattern. Now. Let us read the question together and then we will solve together. Let us read the question together and then we will solve together. Okay. We will go slowly because I want this question all of you should understand. Okay. A resistance seam welding operation is performed on two pieces of 2.5 millimeter thick ASS steel. Oh, it's a long question. So thickness of each sheet is 2.5 mm, and there are rolls here. Rolls are rotated in this direction. These rolls are electrodes. So you will get seam. It's a seam. Okay. So as the data is given, I'm writing here. The weld current in the operation is 10,000 ampere. Okay, na? As the data is given, I'm writing here. Okay. The weld duration is 0.3 seconds. Weld duration is 0.3 second. And the resistance at the interface is 75 micro ohms. Resistance at the interface 75 micro ohms. Continuous motion welding is used with 200 millimeter diameter electrode wheels. 200 millimeter diameter electrode wheels. 200 millimeter diameter electrode wheels. The individual weld nuggets formed in this resistance spot welding process have the dimensions. Diameter is 6 mm and thickness is 3 mm. You will get a weld nugget. Diameter is 6 mm and the height is 3 mm. Dimension is given to you. Assume the weld nuggets are disc shaped, means cylinder. These weld nuggets must be contiguous to form a sealed seam. Sealed means when the one spot finishes, second spot starts. It's a seal, a stitch. The power unit driving the process requires an off time between the spots weld of 1 second. Off time is 1 second. You know what is the meaning of that? Current will flow for 0.3 second. One spot will be formed. After that, there will be a compulsory break of 1 second. Again, 0.3 second. So it goes in fluctuations. 0.3 mm, 1 second. 0.3 mm, 1 second. That's the meaning. Okay. Given these conditions, melting point is 1670. Kelvin. And the specific energy, see here also it is given in this form. So convert it, 3.33 into 10 raised to power minus 6. So you will be 3.33 into 10 raised to power minus 6, 1670 square. It is joules, na? Yeah, joules per millimeter cube. Joules per millimeter cube. So this is the data given to you, okay, na? This is the data given to you. Okay, all right. You have to find out the unit melting energy of stainless steel. This is your first answer. Unit melting energy for stainless steel. This is the first answer. It's the first answer, there is no problem. The proportion of energy generated that goes into the formation of each weld nugget. The proportion of energy generated that goes into the formation of each weld nugget. Because whatever energy is supplied, a portion of energy goes in forming the nugget. See, nugget is also called a spot. Nugget is also called a spot. It's another language. Nugget is also called a spot. So whatever energy is supplied by the transformer, a portion goes in making the spot and another portion by the conduction goes to the plates. So it is asking that one. The rotational speed of the electrode wheels. what is RPM of these electrode wheels. So this is the data available in front of you. Data available in front of you. Give me the answers. Give me the answer. Give me the answer. Digest it. If you want to read the question again, I am putting it here so that you can read it once. I'm standing on the side so that you can read it properly. Try to give me the answer. Try to give me the answer. Try to give me the answer. First, this one. And this is the data. So I want answer of B. You try first. You try first. Proportion of energy. First of all, energy that goes in forming spot. First of all, we have to calculate the energy that goes in forming the spot. It's a U. We have calculated U into how much is the volume of nugget, because that much amount of material is melted. So pi by 4 d square into h. So that many joules. That many joules. Is that okay with everyone? Now, energy supplied. Energy supplied is I square RT. So I means 10 raised to power 4 I square. R means 75 micro ohms. Convert into ohm. T means 0.3. That many joules. So fraction of energy. Fraction of energy will be H1 by H. I want this answer. Arey, very good. Very good. Very good. Yeah, that is also my answer. That is also my answer. That is also my answer. Okay? Now, this was easy. Can you give me the answer for the second bit? Bit is, what is the RPM of this electrode wheel? Diameter is given to you. So V is equals to pi dn. Diameter I know. Somehow, if I came to know V, I will calculate RPM. Let us see who is genius. Of course, some of you are genius already. Those who are seeing the video later on, some of you will be genius. But let us see who can hit. Give me the answer. Let us see who can hit. What is the RPM of? What is the RPM of electrode rolls? RPM of electrode rolls. Let us see who can hit. RPM of electrode rolls. Let us see who can hit. Think over it. Because if I solve directly, what is the fun? If I solve directly, what is the fun? What is the RPM? Let us see if any genius or super genius is present here. If any genius or super genius is present here, let us see what is the RPM. This is correct. Whatever some of you are giving the answer, na, that is correct answer. Okay, na? 0.35. That 0.35 is correct. But I am interested to know what is RPM now. I am interested to know what is RPM. 35. Kushwaha, that is also correct. 34.9 is 35. By engineering approximation, both are same. By engineering approximation, both are same. Arey, what happened to our champions, captain of Indian team? Arey, what happened? अच्छा क्वेश्चन देख लो क्वेश्चन देख लो. अरे rotational speed of the electrode wheel. So I'm telling na rotational speed of electrode wheel. Okay, all right, you know, I will wait, because if there is no pain, no gain. So I want you to struggle little bit for some time before I can give you the answer. I want to struggle you little bit before I can give you the answer. I want answer in revolutions per minute, RPM. I want the answer in revolutions per minute. I want the answer in revolutions per minute. I think nobody this question, everybody is flat. Huh? Everybody is flat in this question. Aja, one more back slide. Lo, quick kar lo. But Rohit, I will tell you one thing. Even the first slide, you will not get anything. Everything is here. Everything is here. It's a waste reading the first slide. Answer will come, whatever is here. Whatever is here, answer will come from there. No, I think I will tell you. It's too much now for some of you. Okay. Look at me. Look at me. No, no answer. I think, look at me. I have to somehow find out velocity of these rolls. Cycle time is 1.3 seconds. Everybody should see carefully. For 0.3 second current flows. After that, there is an ideal time of 1 second. So total time is 1.3 second, na? Total time is 1.3 second. In 1.3 second, how much is the linear movement? How much is the linear movement of rolls? Six mm, na? Because if it is a continuous spot or stage, see very carefully here now. No answer, na? Okay. That's the reason we have selected this question. So it's a continuous spot means, next slide, I will take, see, I will make little bigger figure. 2 sheets. One spot. Second spot. Distance between the 2 spots is a 6 mm, because 6 mm is the diameter of spots. 6 mm is the diameter of spots. So these rolls should move 6 millimeter in 1.3 second. Flash of 0.3 second, and it's a continuous movement. It's a continuous movement of roll. But in 1.3 second, again the roll should come here, because again another spot has to be made. So velocity of roll is 6 millimeter divided by 1.3 second. So 6 divided by 1.3 millimeter per second, or 6 into 60 divided by 1.3 millimeters per minute. V is equals to pi dn. V is here, diameter is here. What is the diameter? 200 mm. 200 mm. Calculate the RPM of roll. Now the answer will come, na? Because I have told you everything. Pavan, Tripathi, Rohit. Now the answer will come, na? Now the answer will come. Because I have explained everything. So it was a really very beautiful problem. Very beautiful problem. It was new. It was not P by Q. Very beautiful problem. So P by Q plus this Abhyas will cover the entire thing. Will cover the entire thing. Because it was a new concept. Because it was a new concept. Very good. Everybody's flat, I think. Everybody was flat. Our all champions were flat. Because it was a new concept, na? I want you to practice one more question. At least the second question you will give me the answer, na? Second question you will give me the answer. Do it. Do it. Do it. If you understood, you will give me this answer without my help. Previous problem. All the data should be taken from the previous problem. All the data should be taken from the previous problem except one. Give me the answer now. One shot series. My classes are November end. There is one question by Vijaya Sai. My one shot schedule is November end. One shot schedule. Okay, na? Vijay Sai, focus on this question. I want you to practice some time for something. I want you to practice. Suppose the previous problem that a roll spot welding operation is performed. Spot welding operation is performed instead of seam welding. The interface resistance increases to 100 micro ohm. And the center to center separation between the weld nugget (25 millimeter). Given the condition from the previous problem with the changes noted here, determine क्या निकालना है आपको? The proportion of energy generated that goes into the formation means H1 by H. The rotational speed of the electrode wheels, RPM. At this high rotational speed, and that C problem I will see later. But you calculate H1 by H and RPM. This you should not require my help. Do it quickly. 2 minutes. I want to get the answer. 2 minutes, because N and H1 by H, you should be in a position to give me the answer. Do it. Third question I will see later. Third bit I will see later. But it's a practice. It's a practice. It's exactly same problem with slightly different data. Exactly same problem with a slightly different data. A and B, you should be in a position to give me the answer. Yeah, 0.26. Yeah, correct. This answer is correct. 0.26. I need RPM. Yeah, Rohit, Karmakar, very good. This first portion is correct. RPM. How much is the RPM? How much is RPM? How much is RPM? How much is RPM? The same funda I used before, same funda you have to use. Same funda you have to use here. Same funda you have to use here. Yeah, RPM is correct. There is no anything. Total cycle time is 1.3 minute. Sorry, not minute. Second. And in 1.3 second, my roll should move from here to here 25. So speed is 25 divided by 1.3 millimeter per second. Calculate RPM, and this RPM is 1.83. Some of you already given the correct answer. Some of you already given me the correct answer. Some of you already given me the correct answer. Yeah. Huh. So these two bits were easy. I hope it is clear to everyone. These two bits were easy, and I hope it is clear to everyone. Now, I want you to read the third bit. It is again funda. First two bits were easy, and the purposefully we have introduced is so that you get some practice. But I want you to focus on third bit now. Third bit. Let us see if you can give me some suggestions. Third bit. At this higher rotational speed, how much does the wheel move during the current on time? How much the wheel move during the current on time? And see here the sentence. And might this have the effect of elongating the wheel nugget? Elongating the wheel nugget. So velocity was, we are solving the 3. Linear velocity was 19.23 millimeter per second. That was the velocity you got, na? Linear velocity of wheel, that's what you got. T is 0.3 second on time. So during the on time, everybody should hear on the screen very, very carefully. It's a relatively new thing. Everybody should hear on, look at the board carefully. Power on time is 0.3 second, and the velocity is 19.23 millimeters per second. So movement of roll, how much it is? 0.3 into 19.23. How much is the linear movement of roll? How much is the linear movement of roll? How much is the linear movement of roll during current on time? So it is coming out to be 5.76 millimeter. So let us say you have this spot. You have this spot, 6 millimeter diameter. Everybody should see on the screen. 6 millimeter diameter. So let us say current starts from here. Current starts from here and up to 5.76. Up to 5.76 millimeter current will continue. This distance is less than the diameter of nugget or diameter of spot. This distance is less than diameter of nugget. So answer is it will not elongate. It will not elongate. Answer is it will not elongate. But suppose this is 6.7 millimeter and the spot is 6 as per design. Now it will elongate by 0.7 millimeter. It will elongate by 7 millimeter. So in case of spot welding, during the current on time, you should know how much is the linear movement of electrode. It should be less than the diameter of nugget. It should be less than the diameter of nugget. Correct? Are everybody is okay? Is it okay? Everybody is okay? Is it everybody is okay? Correct, na? It was a very good problem, beautiful problem. So last 20 minutes, we learned lot of new fundamentals. Lot of new fundamentals we studied in the last 20 minutes. So I am going to the next problem. Next, another beautiful problem. And this problem also you might not have seen. This problem also you might not have seen. So एक से बढ़कर एक हो रहा है actually आजकल. एक से बढ़कर एक हो रहा है. Read the problem. Very beautiful. Again, another very beautiful problem. Very beautiful problem. An experimental power source for spot welding is designed to deliver current as a ramp function of time. Meaning, current versus time is this. And the equation is I is equals to 1 lakh 10 raised to power 5 t amperes. Okay. At the end of the power on time, the current is stopped abruptly. The sheet metal being spot welded is low carbon steel, whose unit melting energy is 10 joules per millimeter cube. (10 joules per millimeter cube). The resistance is 85 micro ohms. 85 micro ohms. The desired weld nugget size is diameter 4 mm, thickness is 2 mm. Thickness is 2 mm. It is assumed that 1/4 of the energy generated from the power source will be used to form the weld nugget. Means efficiency is 25%. Indirectly, the question is saying efficiency is 25%. So only 1/4 of energy is used in making the spot weld nugget. 3/4 goes to the heat affected zone. Determine the power on time. Determine the power on time. The current must be applied in order to perform the spot welding operation. We have to find out the power on time, meaning power on time. Just digest the problem. I'm again putting the screen. Just digest the problem. We will solve together. Just digest the problem, we will solve together. Digest the problem, we will solve together. Digest the problem, we will solve together. Okay, so the energy (10 joules per millimeter cube). How much energy is used to make this nugget? Is nothing but 10 multiplied by the volume, pi by 4 d square into 2, that many joules. How much energy is supplied? Because I follows a function. Let us say my on time is t. Take one element of dt. So the energy supplied by transformer is nothing but integral 0 to t I dt. I square रबड़ ले लेते हैं, I square r dt. I square r dt. The value of I is 10 raised to power 5 t square. R value is given 85 into 10 raised to power minus 6 dt. Now let us say this is h. So h by 4 should be equal to this u. Find out t. Do it. How much is the answer? Understand? Na? Because if the profile is given, we have to integrate. That is a new concept. If the profile is given, we have to integrate. Can you give me the answer quickly? Can you give me the answer quickly? If the profile is given, like here there's a profile, we have to integrate like this. Can you give me the answer quickly? Solve it quickly and give me the answer. Solve it quickly and give me the answer. Solve it quickly and give me the answer. Oh my God, very fast. Rohit is very fast. And that is the correct answer. And that is the correct answer. So only new thing I have taught you in this question is, if equation of the current profile is given to you, we have to integrate like this. It can be any profile. It can be any profile. And if the profile is given to you, you have to integrate. If the profile is given to you, you have to integrate. If the profile is given to you, you have to integrate. Answer is 0.152 second. 0.152 second. That will be the answer, and most of you are getting the same thing. And most of you are getting the same thing, 0.152. The concept was, if the profile is given to you, you have to do exactly the same thing. So in today's lecture, we have seen some beautiful problems on welding. Tomorrow is my last lecture of Abhyas. Tomorrow is my last lecture of Abhyas, and there I will be discussing automation. Automation, primarily, I will be discussing very beautiful questions on apt automatic program tool. Get these question comes. And the questions based on some stepper motor. And also questions on G and M programming. So, in the tomorrow's lecture, I have taken a blend of new questions and slightly modified complicated PYQs. So those who want to attend, 11 o'clock, I will discuss all these questions 11 to 1. And tomorrow is the last lecture of Abhyas. After that, we will be meeting in our regular batches or one-shot courses. So thank you very much. Good afternoon to all of you. See you tomorrow at 11 o'clock.